Algebra 2, we have 8.8, our last problem in this lesson. It's at the very end of our notes. Solve for x. We've got two logarithms in this equation, much like our last problem. This one's honestly going to be more complicated. You're going to see why in just a moment. But of course, at the end of this problem, we'll have to do a check. And we have to be aware that we have to check the insides. Whatever x value we get, we want to make that the insides of both of those logarithms are not negative and they're not zero. I'll tell you what, I want to get my logs next to each other so I can combine them. I'm going to add a log base 5 of x minus 7 on the right and the left side. And the reason why I'm doing that is we've been studying properties of logs. We've been learning that when you add two logs together, you may condense them. You may combine them. And what we saw even a couple of days ago is that the log base b of m plus the log base b of n may condense into one log with the same base, but you multiply their insides. So I'm going to do that. I'm going to say, look, I'm going to have x minus 3 multiplied to x minus 7. And I'm just going to have one log. Our problem has actually gotten easier. We only have one log instead of two. Now, of course, inside you might see something that looks like we should FOIL. We should multiply together, and we can. X times x is x squared. X times a minus 7 is a minus 7x. Here we'll get a minus 3x. And negative 3 times negative 7 is a plus 21. And combining our like terms, negative 7x minus 3x, well, that's going to become minus 10x. And there you have it. We have FOILed. But of course, right now, as we're looking at this, we probably should say, hey, could we do a log circle? And we certainly can. You can say this is going to become 5 to the 1 power would equal x squared minus 10x plus 21. That's the wonderful definition of a log, this log circle. 5 raised up to the 1 power is equal to, look at the last part of the circle, x squared minus 10x plus 21. Well, 5 to the 1 is just a 5. And you can see right now we have a quadratic. And with quadratic equations, we need a 0 on one side. So I'm going to minus 5 from both sides to get rid of 5 on the right. We'll have x squared minus 10x plus 16. And guys, right now I'm going to rewrite this problem at the top so we have some more space. However, what you're going to see me do is I'm going to put the right side on the left and the left side on the right. Same problem, same equation, of course. And right now you might remember when we had to factor. We're going to factor here. We're looking for two numbers that will add to negative 10, but at the same time, those two numbers will multiply to 16. And a positive 16 at that. You can think, well, how can we do that? Let's think about the ways you can multiply to 16. Multiplying to 16, you could have a 1 and a 16. You could have a 2. A 2 times 8 is going to get you 16. And of course, you could have a 4 and a 4. But as we're searching here, I do want you to realize if you're multiplying to something positive, but you have to add to something negative, you're going to require that both of the signs have to be negatives. And if the signs were both positives, you'd multiply to a positive, but there's no way you could add to the negative. And if you had a mix, if you ever had one positive and one negative number, that wouldn't multiply to a positive 16. So here are our only possibilities. Which one of these will add to negative 10? Well, not negative 1 and negative 16. That adds to negative 17. Negative 2 and negative 8 do work. Negative 2 plus negative 8, losing $2, losing $8, it's like losing 10. Obviously, a negative 4 and a negative 4 won't work. So you'll have x minus 2, x minus 8. And then you have to set both of these equal to 0. And it only takes a moment to solve. You'll get x is 2. Here you add an 8, you'd get x is equal to 8. And it's so easy to want to stop, but guys, you really do have to do a check. I'm going to do a check over here with x equals 2. Now, if you look in the top left corner of the screen here, you can see that there's an inside of that one log and an inside of the other. I'm going to have to check what's happening with x minus 3. I'm also going to have to check what's happening with x minus 5, or x minus 7, pardon me. And when we plug in this 2 minus 3 is negative 1. That is a negative number. It fails. This is no good. X cannot equal 2 in this problem. You don't even have to check this other x minus 7. I mean, it's negative as well, but even if it wasn't, you're still done. It fails. For the first time in this lesson, we're seeing that a number could get plugged into a log and get you something negative inside the log. That can't be allowed. We should also, though, check 8 and see what's happening. We're going to have to check the inside of x minus 3. We're going to have to check the inside of x minus 7. And when we do that, we'd have 8 minus 3, which is 5. Hey, that's a positive number. 8 minus 7 is 1. That's also positive. This is good. So we only have one answer, and that is x equals 8.